So in this example, we are going to use Fleury's algorithm here to determine whether a graph has an Euler path or an Euler circuit. And Fleury's algorithm is pretty straightforward and pretty simple. Most of it is already dictated by Euler's theorem, and that is the first thing we do is we're going to look at the vertices, and we're going to see the degree of the vertices. And if a graph has all even vertices, then we could start at any vertex and it's going to have an Euler circuit. However, if it has two odd vertices, then we know that it's going to have an Euler path, and we have to start at one of those odd vertices, and we're going to end up at the other odd vertex. Then they also ask that you trace or number the vertices as you cross them. We're going to use, or I'm going to use a red pen to go ahead and outline it. And the other thing is if you encounter an option, and one of the options is a bridge, don't use the bridge. Now, we don't have any bridges on here, but as far as the vertices go, we'll start with A. This has 1, 2, 3, 4. This is degree 4, degree 2, degree 4. This has degree 3, so here's an odd vertex. Degree 4, degree 1, 2, 3, 4 is a degree 4 here, degree 2, degree 4, and degree 3. So we have exactly two odd vertices, so there's going to be an Euler path. We'll start at either D. If I start at vertex D and go ahead and create my path, I'm going to end up at I. Or if I start at I should end up at D. But you just have to kind of plan it out a little bit. Be careful where you go. I like to stay away from the vertex until I'm ready to wrap everything up, the odd vertex. But I'll start with I, and I'll go up to E. There's 1. Here's 2. We'll go down here to G. There's 3. 4. Now I could either choose to go up to I, or I can choose to go up to H. I'd rather go up through H. Like I say, I like to kind of avoid this if I can. So here's 5, 6, 7. Come across here to C, 8. I'm not necessarily going to go this way, because I'm going to try and avoid this as much as I can. So how about if we go this way? Here's 9, 10, 11. Now I have no choice but to go down to D here. 12, 13, 14, and finally ending up at the other odd vertex, and 15. So we have 15 edges starting here, following our path, and we end up at D. And there we go.